Alright, so welcome to our 6th video of our 4th unit of general chemistry, or honors chemistry, depending on what class. Okay, moving on. This is called Enthalpies of Reactions. So, the enthalpy change of a reaction, denoted by delta H, it's actually wrong, I really don't know why you're missing something. Sorry, typo. That typically is Rx in. Delta H refers to enthalpy change, and Rx in refers to reaction, so that is the enthalpy change of the reaction. Go figure. Represents the change in enthalpy as the reactants are turned into products. Typically, this is the long version. We shorten it to this. But what it comes down to, it's the enthalpy difference between our products and our reactants. So this ends up being positive. That says our products have more. If this ends up being negative, our reactants have more. So there you go. This goes back to delta referring to change. Hopefully you remember that delta T equals... TF minus TI, where TF represents final and TI represents initial. This is basically our final state of the reaction as products minus our initial state, which are reactants. So, same concept. So, as I mentioned, if delta H of a reaction is negative, that means that the products have much less, or that has less energy than the reactants, thus that is exothermic. For example, a nuclear bomb. This will produce a ton of energy. That means that it likely has a lot of potential energy. It now releases it and is extremely exothermic. Again, our delta H, negative, exothermic. Alright, exact opposite. Delta H is positive. That means the products have more energy. The reaction is endothermic. For example, a cold pack. It'll start off cold, and then basically over time will actually keep absorbing energy. That's how it's cooling you down. It's taking your energy, but eventually that will warm up and thus eventually get warm. So there you go. All right, so the production of iron and carbon dioxide from iron 3 oxide and carbon monoxide is an exothermic reaction. How you knew that? Well, I'll show you in a bit. How many kilojoules of heat are produced when 3.4 moles of iron 3 oxide react with an excess of carbon monoxide? Okay, so first off, typically there are two ways to see whether it's exothermic or endothermic. A is this way, in that your energy is going to be either reactant or product. If it's a product that says we're producing energy, that means exothermic. If we're a reactant, that means endothermic because we have to react with energy. Sometimes you'll also see, and the way we can also write this, is that delta H equals negative 26.3. Because that says that when we're actually done with our reaction, our original reactants are going to also give up 26 kilojoules. That means we're overall going to lose 26.3 kilojoules. So this reaction is exothermic. What this says is that for every 1 mole of this and 3 moles of this react, I'll get 2 moles of this, 3 moles of this, and 26.3 kilojoules. That also says for every 2 moles of this that are produced, I'll get 26.3. Or for every 3 of this is produced, you get 26.3. Hopefully you're kind of getting that for any coefficient moles of these, we get our enthalpy change worth of joules. So they're asking, what about 3.4 moles? Well, this is kind of like stoichiometry, and I know that'll scare some of you, but it's much, much easier. So we are starting with 3.40 moles of Fe2O3. And we're trying to figure out how many kilojoules of heat are produced. Well, the only thing I know is that I produce 26.3 kilojoules of energy every time this equation happens. If I look at Fe2O3, I know that that will happen when I have 1 mole of this reacting, plus they say an excess of CO, so we're assuming I have plenty. That says this happens with 1 mole of Fe2O3. All right, and once you multiply those together, you will get 89.42 kilojoules. So that basically is saying that we know that we will get this many kilojoules when 1 mole of this reacts, or when 3 moles that, etc. However, we have 3.4 times that amount, so we should be getting more kilojoules. And there you go. That is our total amount. That's really about all you do. It is similar to stoichiometry, I know, but it's not that bad, hopefully. All right. When carbon disulfide is formed from its elements, heat is absorbed. Now, hopefully your first thought should be, oh, endothermic. If heat is absorbed, endothermic. If it's not your first thought, then you're, well, probably sane, because honestly, most people don't really think that except for like chem teachers. But still, if you did, yay. So, now we need to calculate the amount of heat in kilojoules, which means it's probably going to be a big number, or, oh, wait a second, we start in kilojoules, so we don't really need to change it. When 5.66 grams of carbon disulfide is formed. All right, so we are starting with 5.66 grams of carbon disulfide. All right, so here's the thing. We don't have this equation set for grams. We have this equation set for moles. In fact, I know this will happen when 1 gram of carbon and 1 mole of carbon and 2 moles of sulfur react to produce 1 mole of carbon disulfide. But again, I don't have 1 mole. I have 5.66 grams. As you're hopefully hoping or thinking, yes, first step is to convert that to moles. Second step is to convert that to joules. So, first, we're going to 1 mole of CS2 on top. And we actually need to find our molar mass. So carbon is 12.01. Sulfur is, there's 2 of them. Basically put them together. You get 76.15. All right, and then we also know that we are going to be using 89.3 kilojoules for every 1 mole of CS2. So that means our grams will cancel out, our moles will cancel out, we'll be left with kilojoules. So multiply the top, multiply the bottom, you'll get your final answer. That all will basically be 505.4 over 76.15, which, when you actually put that in your calculator, you will get, when you put that in your calculator, you get 6, sorry, I'm trying to look at my calculator, 4 kilojoules. That's your answer. Yay. Not all that bad. All right, here's some practice. If you're in class, you're probably just going to pause it right now. So if not, thanks for watching, and have a good day.